My name's David Burrell. I'm the manager on our developer architecture team. So we do graphics and performance, and I'm also deeply involved in a lot of our SDK efforts. So if you're using Unity, Unreal, native OpenXR, you have any questions, feel free to find me and we can talk about it.
Hello everyone, my name is Mike Lambrinos. I'm a product manager on the developer tooling side. So I know some of you in the room using our tools. I'm really excited to talk today about all the new things that we're bringing to you and just see how developers get to use the tools and what new things you build with them. So yeah.
Awesome. So today we'll be talking about tools at a few different levels. Part of this talk's goal is to give you kind of a big picture understanding of what our tools are, how they fit together, when to use which ones. And then we'll do a little bit of a deep dive on performance analysis and another kind of lay of the land there. So let's talk about building for Quest as a whole. We know that a lot of folks see a lot of possibilities there, that there's a lot of amazing things you can do, and we haven't even scratched the surface yet. So it's always amazing to see the next thing that you all build. We really believe this is going to grow and that there's going to be a huge addressable market. We're trying to bring more and more people in the door and give you more and more access to revenue and growth, and that we can all be on this journey together and really bring out the most of VR's potential. That being said, there are some challenges. We know that, for example, edit, compile, test iteration time is hard. There are a lot of unique issues with the form factor that you have to contend with, human-computer interaction challenges, and also performance analysis. It's such an immersive and demanding workload that we're putting on a device that's really designed for mobile workloads for the power budgets that the device can handle. So we often see developers encountering similar problems over and over again. So one of our other goals here is to try to help you navigate some of those problems. But yeah, I want to emphasize that we're here for you, and a lot of the work that we're doing on developer platform is to try to understand your feedback and your experience, and take that back into the product and make it easier for you to get to the finish line, and also help you make some more money once you ship. Mike?
Thank you. So I'm going to start talking a little bit about some of the foundational tools that I know many teams use every day to help them start building for Quest or go deeper in some of our capabilities. You can see the names of some of the tools that we're going to talk about today. And I'm really excited to talk about the big updates coming later this year for some of these tools and some new ones that our teams build based on your feedback. I think it's interesting to touch on why are we doing developer tools in the first place, right? Why are we focusing so much in developer tools? And we have one of these sessions every year. So I was actually curious on a personal level, how do teams use those tools, right? And do we see more success for teams that use the tools? And basically what we found is that 4 out of the 5 highest revenue apps that were released since we were here last year actually use some of our foundational and core tools, like building blocks or project setup tool. So we think there's a big correlation around using some of those tools and finding success. And there are 2 reasons behind that I personally think influence that. The first is that we're moving to a world that creating content is becoming faster and faster, right? So it's super important for you and your teams to make sure that they can experiment fast. That if you have an idea of, hey, it would be great to use this capability to build this VR game, that you can do that very, very fast and get a signal from the market. Is this something that has product market fit that makes sense for me to really spend the months or years to develop it into a proper game? Or should I move to something else? So iteration speed is something we're super laser focused on unlocking for you because we know that it is connected very much with success. The second one is, how do we help your teams lower their development costs? And that we know has a lot to do with some of the flows around iteration, debugging, and all the long process that it takes from actually building the game to shipping it to tens or hundreds of thousands or millions of users, right? We know how much time and effort and money that costs, and we want to bring that down. So we think those are some of the reasons why people use the tools. The data support this, so we take it very, very seriously to make sure that we deliver a very, very good developer experience to you, both in terms of reliability, but also enabling your teams to find success. And I'm going to start today to talk a little bit about MetaXR Simulator. MetaXR Simulator is a tool we have since 2023. And I picked this quote from Julian, who I think is in the crowd. He's the developer of Lasertag, one of the most fun MR games, I think, of the last year at least, personal opinion. And here, Julian talks about how MetaXR Simulator really enables some use cases that would be almost logistically impossible without using MetaXR Simulator, right? Having to test with like 10 or 15 headsets, I know it's something that some studios just cannot do physically. So MetaXR Simulator has become this really important tool to enable some of the use cases that otherwise would be impossible. And that's why we spent a lot of time on really updating the core part of MetaXR Simulator. So later this year, you will see a completely redesigned version of MetaXR Simulator coming, where we focus a lot on two things. One is reliability. So every time you click the play button in Unity, that you have MetaXR Simulator connected, that it's actually going to run, and it's going to be a very reliable experience to test the game. But also super, super important is simplicity. So in the past few years, we've added a lot of different features to MetaXR Simulator. Things like multiplayer, but also major quest features, pass-through, controllers, hands. So we want to make it super, super easy when you're simulating something to find all those different features. Of course, everything that you already know and use is going to be there. Things like capture and replay. We talked about multiplayer. And you can even connect your headset so that you can simulate your Quest controllers, use your Quest controllers while you're simulating a scene at XR Simulator. It's a pretty interesting update. And I know this is the last session, but if you head over to Building 15, we have a booth there with MetaXR Simulator where you can try it today. If you're a first access developer, you're going to get access to the new version in a few weeks, and for everyone else later this year. I'm personally super excited for you guys to try MetaXR Simulator. And I also want to highlight one more simulator that we're putting out this year for our Android developers. So if you're building any 2D app or any app with the Spatial SDK, the Metaspatial Simulator is going to be available for you right into the Android Studio and the Meta plugin there. So changing gears a little bit and talking about another tool, building blocks. So we've introduced building blocks, again, about 2 years ago. And building blocks really help you get started fast with prototyping, but also be this base when you're creating a new project from scratch. We focused a lot in the last year on getting 2 use cases really, really easy for you. One is multiplayer and all those like social experiences with a selection of multiplayer building blocks. This is out already, and I know many of you are using it. And it takes the complexity away from having to do all the plumbing, all the different like networking layers, as simple as drag and dropping a building block into your scene. Now, building blocks, of course, are Unity prefabs. So that means you can customize it very easily. And we made it even easier to like break the building block so you can continue your development without having to rely on just the code there. You can just right-click and basically continue building with the code that is already there. Another interesting use case that we explored in the past year has been around the tabletop games, mixed reality tabletop games, a category that we see many new experiences in the store. Now, what's really interesting is that, again, I checked the data so you guys can see how these tools have influenced some of the studios that have been using them. And 27% of all of the apps published since Connect last year have used building blocks or adjacent tools like Project Setup Tool or Immersive Debugger. So for us, it's super important to keep updating building blocks with all the new XR capabilities. So there are a couple of things that are coming with building blocks with V83, which is launching very, very soon. One is pass-through camera access building blocks and AI building blocks. So we think building blocks is this platform that can really help you take very complicated capabilities, and you don't have to worry about exactly like the nuance of how it works. You can focus on creating something with it and see if there is a concept there that you want to take to market, rather than read the documentation, go deep on the API, et cetera. So we're focusing now on taking pass-through camera access to building blocks and make it as easy as possible to build some of those use cases with those new capabilities. Obviously, like we have seen all the great stuff that you build with PCA, but I've spoken with some of your teams, and I know that you need to understand like machine learning and some concepts that many teams don't really have an in-house expert, right? Again, I think you guys focus a lot on the actual game, the actual experience, and this type of technology might not be familiar with your team. So that's where those building blocks come into play. You don't have to worry about going down like really into the detail of how you build with those capabilities. We take care of that. So you can focus on, hey, I have this cool experience. I have this cool idea in mind. How can I see if there's something there? So pass-through camera access building block is coming with V83. And something also really, really exciting is the AI building blocks. So this will make extremely easy to plug in an LLM of your choice into your project. The prefab we're putting out is with Llama, but the choice is yours to use the LLM that you're more comfortable with. And we're also shipping some building blocks around speech-to-text and text-to-speech. So I think all of those things together really can give you the capabilities, even if your team doesn't have the in-house expertise, to try some of these cutting-edge technologies. If you haven't used building blocks yet, here is a QR code on our documentation page just to get started. It's part of the Meta XR all-in-one SDK in the Unity Asset Store. And V83 will have these building blocks that I talked about today. Now, talking a little bit about our other core tools, again, tools that we know that are deeply integrated with your workflows, Link and MetaQuest Developer Hub. We know that people use these tools daily, and we have been focusing a lot on the stability and the quality of those tools in the past year. We know how critical that is, and we're continuing to improve the reliability in every version. Now, we are reading your issues and your bugs through the feedback hub in MetaQuest Developer Hub, so please keep sending us any issues that you find there. We're going through the backlog of those, and you should see a better and more reliable experience in every single release. Lately, especially for MetaQuest Developer Hub, we focused on improving the ADP path, and I think it's worth calling out that later this year and next year, you will see some new features on those tools once we feel they're in a stable state. Now, a tool that we talked about last year as well, and it was an experimental tool at the time, was Immersive Debugger. Immersive Debugger helps you debug faster when you have to put on the headset, and it gets really, really integrated into your project. It's a really customizable tool, so it helps you monitor, visualize, and troubleshoot different things from your runtime right into the headset, so you don't have to take the headset on and off all the time to just change a few things. Beat Studio, the creators of Beat Saber, have been using it with great success. And since earlier this year, we graduated this tool from experimental. Later this year, Immersive Debugger is going to get a really exciting feature. We're going to have a set of AI features that you can basically automate a lot of the different tasks that, for example, your QA team might have, or even you when you're debugging your game and you want to see how things would be different. And the only thing that you have to do is just talk to the AI, and the AI will make the changes for you. So that's coming later this year. But Immersive Debugger is already a really, really strong tool. And with AI, we want to push this even further. Also, this year saw a big release from our partners in Unity, Unity 6. It has, I know that many studios are using Unity 6 now to start new projects. I think it's a fairly stable state. And I want to highlight the improvements for MetaQuest developers. We saw the introduction of build target for MetaQuest. You don't have to go through anymore through any of these like hacky processes when you're building for Quest. It's a build target now, and you can adjust the quality of the build and the configuration like you would do in a normal PC or mobile project. We've also integrated many of our automation rules that you find in Project Setup tool directly into that path, which makes things a lot faster when you're starting the project. Now, let me quickly recap what we talked about today. A major update to MetaXR Simulator, which is coming later in the year. And again, you can have a preview and a demo of this in Building 15, just after this one. Building blocks, which we're going to focus a lot on simplifying pass-through camera access and AI. First release coming with V83, but this is an area that we really think building blocks can be the platform that help you experiment with what's really cutting edge right now in VR development. Also, Immersive Debugger, which has been graduated from experimental, and we're going to have an AI assistant right integrated inside the tool. And also Unity 6, to make sure that when you build with Unity, your life as a developer is much easier. Now, we talked about starting, or some of these tools are part of your development flow throughout, but I know performance is such an important topic for many of you, right? Like, how do you push the limits of what the device can deliver? How can you really take that to the next level? David is going to take over and speak about some of the performance tools that we have for you.
Thanks, Mike. So, yeah, I mean, I guess first off, I have a question. How many of you have gotten into development, got something working well on Link or on your PC build, and then the first APK that you deploy to a device is stuttering and you have no idea why? Okay, yeah, that was kind of expected. It's almost a rhetorical question, but like basically everyone. So this is a problem that everyone goes through, and it's worse on our platform because of the demands on performance that immersive compute implies. So we have a lot of unique problems, and we also have a lot of tools we've invested in to help you with that process. So let's talk quickly about the lay of the land here. We have Meta Runtime Optimizer, which I'll actually get to at the end, that can be kind of a one-stop shop. We've just shipped this recently. It's in beta right now. And in fact, if you go down to Building 15, we're demoing a version of it that uses AI and an MCP to give you even deeper insight into performance bottlenecks. But stay tuned for the release date on that. But you get a little sneak peek if you go down there today. Those of us who have used OVR, actually, how many of you have used OVR metrics? Yeah, okay, it's super, it's like definitely our most popular tool after maybe like Link and MQDH. Don't quote me on that, but it's very, very popular. The RenderDoc GPU performance analysis tool that Neil mentioned in a previous talk, we'll give it a little bit more discussion here. And Perfetto are kind of more specialized for the types of problems you would discover in those first tools. So if you have OVR metrics, you have Runtime, Performance Analyzer and MQDH, drop into these other tools. So I'll talk about that in a moment. But what I'll do is kind of give you the big picture of kind of when to use what tool. And then we'll talk a little bit more specifically about RenderDoc and some of the other tools. So generally, we expect developers are going through this kind of a flow when they have a performance problem. So Unity itself has a great performance analysis flow. If you're not targeting XR, you're just working on PC or Android or iOS, you may be very well aware of how you can edit your script code, hit play, see what the profiler says, and then zero in on exactly what script is costing you time. And we're not trying to change that great solution. But when you deploy to device, you may discover additional performance bottlenecks. And Unity's profiler may not always have the answer. So here's kind of where I would go from there. So you're in Unity here, and you deploy an APK to your device, bring up OVR metrics tool, and it says something's wrong. Well, one thing you can do is kick right back into Unity's profiler and do some frame analysis. They have a great frame debugger and things like that. I'm not saying anything is wrong with that. But it doesn't connect and get as much data from our device as some of the other tools can. So a common other solution you might have is RenderDoc for GPU-based problems, or Perfetto for CPU-based problems. And similarly, within Unreal, there's the Insights Profiler, which is very powerful and has a great deal of rendering information on PC, but then you may feel a little bit in the dark on Android, specifically with Quest, and then RenderDoc is extremely powerful in that case. So once again, Unity's built-in profiler has a couple of different views. And one thing that really delineates the different tools is what their UI kind of shows you, how the information is organized. Actually, I'm not sure how many of you are familiar with ETW on Windows. There's this great kind of consolidated way of logging events on Windows called event tracing for Windows. And those events can be enabled or disabled very granularly. So you can enable a huge volume of these events. They have very low overhead, and then you can look at those with tools like Windows Performance Analyzer or GPU View, or even the security auditing tool. Like all of these tools have different views into that same kind of database of ETW information, and it can give you things like call stacks. So the analog to that on our platform, we have a couple of systems that we can use to annotate your code. One of them is Perfetto. So Neil talked about that in a previous discussion. Like the key to Perfetto is there are many different markers on Android. There are A-trace, and there are Perfetto markers themselves, and some other sources. And many times people will give you like polymorphic markers that can emit different types of telemetry. But it all bubbles up to these trace files, and it's kind of like a sequence of these begin-end markers, and they tell you what time one event occurred, like the opening event, and then what time the closing event occurred. And hierarchically, you can look like, oh, how much time did I spend in this call stack, and each function successively until you have like the exact thing that took all your time. So with Unity and Unreal, they both have profiler frameworks like this. So if you look at the engine code in Unreal, you're going to see a lot of these like begin and scope kind of declarations that are either explicitly being done or implicitly by C++ object-oriented stuff. But generally, they're starting and stopping timers that can be looked at as a timeline, can be looked at as a flame graph, which is kind of a hierarchy that tends to end up making a lot of kind of flame patterns on your screen. But basically, it's like function X is taking 100 of my time unit, and then function Y is taking 80 within that, and you can look and see kind of drilling down. So those activities are very efficient if you can meaningfully analyze your performance on Windows or Mac or Linux. But once you're at the state you want to be there, Android and specifically VR can behave a little differently. So you can connect Unity's profiler directly to your Quest, and you can see some degree of that CPU information coming back. Unfortunately, due to the nature of our GPU, we have a tiled GPU, and when you submit a draw call, it's going to be run across a bunch of tiles which retire at not exactly the same time. It's very hard for the driver to tell you exactly when a draw call began and ended. It can be harder for Unity's traditional GPU profiler to work in that scenario. Minor trivia on OpenGL ES, we did for a while enable that kind of information, and what we found was it was kind of directionally helpful. But what developers tended to prefer was RenderDoc, which I'll talk about in a minute. It gives you much more reliable and in-depth information. And similarly with Unreal Insights, the GPU profiler there is wonderful, gives you those kinds of hierarchical or timeline-based timings. And sometimes you want to look at that in the context of your game object hierarchy. You want to see the sequence of frame drawing commands that was going on in the engine and annotate that back to the source where you can fix it. But sometimes the problem is harder to diagnose, and so you want to kick out to another tool. What you lose there is kind of that context about what to do about it. So you're going to need more metadata and the ability to A/B experiment so you can narrow down what exactly in your configuration is causing that. So that's just one kind of razor to keep in mind about which tool to use when. It's also worth noting that Unreal's profiler is the only way you can really debug Blueprint. So Blueprint is Unreal's visual scripting language, and I'm not aware of any other great profiler for that. OK, so going back to OVR metrics tool. So I know that you've all used it, but you may not know what all the stats are. We have just the raw CPU utilization, GPU utilization. We can tell you how much memory you're consuming. But we also have a number of statistics that we've worked with Qualcomm to expose. And for example, we can tell you like cache misses that are occurring and help you just see in a streaming view that's non-invasive to your app kind of what is going on in the system and if there's a problem at all, and help to give you some kind of directional information to drop down into the right tool next. So there's more documentation on exactly what each of these stats is. You may note that the text is a little blocky. The reason for that is that we're rendering it as efficiently as we absolutely possibly can because we don't want to perturb your performance. So the goal is to give you accurate information. But yeah, you can also configure it to show you different information in different situations. Yeah, check out the docs on that one. But it's actually more configurable than you may think. A lot of people just install it, bring it up, and hide it, and never think about that. But it can give you almost enough information to just go and solve the problem without dropping into any other tools, which is way faster. OK, but if you're not in your headset, like if you're working on your IDE or if you're right in Unity and you want to hit build and run, push to device, and just immediately see results without donning and doffing your headset, which, let's be honest, it takes a little time, you can use Performance Analyzer. So this is a UI that shows similar information to OVR metrics, but it's built right into a MetaQuest Developer Hub. How many of you actually use MetaQuest Developer Hub? Wow, I'm actually really happy to see that. Yeah, MetaQuest Developer Hub is kind of a one-stop shop for a variety of things, and I hope you found the profiler in there because yeah, it can avoid round trips putting on your device. And actually, this is implemented using Perfetto in the back end. So you can enable different amounts of instrumentation here and try to minimize the impact on the performance. But since we're rendering the actual UI on the PC, it's obviously a lot more in-depth than the OVR metrics one. OK, so Neil talked a lot about Perfetto. I'm not going to rehash everything he said. But the upshot of this is that it's a timeline view of all the resources on your system. So I think we are at currently 6 cores for the application, most of which are reserved. Many of the DSP and the motion estimation unit and a number of other functional units on our system on chip are actually reserved for the system because rendering and tracking VR is really computationally intensive on its own. But we try to rigorously keep the CPU and GPU and memory available to you so that you can depend on that. And so you will clearly see inside Perfetto, your app cores and what you're doing on them. So Neil described a technique where if you see a thread sleeping, you can watch for when it wakes up or what it's waiting on, and try to understand maybe there's a binder call on another thread. Maybe it's not even on one of your cores that is being waited on. So Perfetto is the first place where you start to see that operating system contention with your application. And so you could see the kinds of things that are causing stalls. Similarly, on the GPU, you may be having faults, or you may be having other penalties because of cache misses or other things that you can start to see, like, oh, the graphics driver is waiting. Don't be overwhelmed when you first open Perfetto. It kind of shows you all the information at once, like that Matrix scene where they ask for all the guns, right? But the idea of Perfetto is that you quickly zoom in on one frame and then try to tease apart all the different threads and all the different dependencies. And we give you the call stack information and a lot of other things so that you can get past that information overload stage and start drilling in on the thing you're interested in. Lots of great documentation from Google on Perfetto as well. RenderDoc is one that you would use more for graphics problems. So if you're in Unity and you're seeing a lot of GPU utilization, or if OVR metrics tool is telling you, I'm having stale frames because the GPU utilization is at 100% and there's something going over limits, RenderDoc is where you can go in and see every step of your graphics command stream. So when Unity renders your game, it speaks to the graphics driver through an API called Vulkan. We recommend Vulkan over Glass nowadays, but for many years, I'm sure, how many of you are still using Glass? How many of you don't know? OK, so yeah, OpenGLES is another API you can use to talk to the graphics driver. It's kind of the old thing. And the difference is that Unity has a lot more control over the fine-grained way that Vulkan actually does the rendering, as opposed to having Qualcomm have to implement that for you in the driver before. We don't need to get into that. But RenderDoc will tell you all those Vulkan commands in a timeline. You can click through them and see what impact they had on the image. So then you can say, oh, that's exactly where my garbage mesh caused a bunch of screen corruption, or the not a number that I submitted because of a divide by zero blew up my animation, and so now my character looks like a mutant. So that's the kind of thing you normally do in RenderDoc. It's really a debugger. But we've added a profiler to it. And so now you can say, okay, everything's rendering correctly, but somebody on my art team like massively over-tessellated the shoelace on that shoe, and there's hundreds of thousands of polygons there, and of course that caused some stale frames. And you can see that right there in the time cost of submitting that draw call and rendering a number of primitives. And so that's the kind of information you would get from stepping through RenderDoc. It also gives you nice portable traces, so you can capture a trace and then rerun it in automation repeatedly. So it's a pretty powerful tool. I should also mention that our collaboration with Qualcomm, we've got a bunch of statistics about the rendering that you might not get from other Android devices. This is the kind of information you would expect coming from Xbox or PlayStation. Those graphics drivers, and also on Windows, NVIDIA and AMD drivers, give you a lot of information about queue occupancy and render stages, as well as the cache behavior and a bunch of other things. So those statistics are annotated in RenderDoc as well as in Perfetto, so you can see how they're developing over time. Those can often point to smoking guns if something bad is happening in the rendering. So all of that may make you feel like you have to become like a PhD in graphics to even get anywhere with your development, but that's not true. Some of our tools are designed to just help you fix the problem and move on, or just teach you what you need to know about the problem that's occurring. And we've tried to take that to the extreme with this new tool that's been in beta for a couple of weeks now, Runtime Optimizer. So this is a tool we've built directly inside Unity in scripts that uses that information from Qualcomm. We call that the Profiler Interface Library, the PIL. And it also combines other performance information from Unity. And it allows you to A/B compare different configurations and understand the performance difference between them, which can tell you, what might improve if you made certain changes in your app without actually making them. And it can also kind of point to problem resources for follow-up. And in the demo downstairs, we take it a step further by having AI actually make a recommendation about a change. So you could almost have like a, make my app faster button. So let's talk a little bit about how that works. So it's a tool inside Unity. Here's where it is. You can check out the YouTube video later for follow-up. The documentation is also pretty good about this. But yeah, you can find a scene in your app that is giving you performance trouble. And then there's a tool in our toolbar, or there's a menu you can click into, open up the tool. First thing is to capture a trace. So it's telling some statistics here. We've got a couple of traces, and it'll tell you, what your performance was overall in terms of FPS, and also how much memory you consumed, CPU and GPU, and some more detailed statistics there. But that's not all. You can also assess the potential performance of changing those configurations. So if you don't do that, the first thing it'll tell you is this resource costs a lot of performance. You might want to inspect that. And then if you do a follow-up A/B comparison, you can actually see what kinds of changes would be necessary to hit frame rate. So here it is with the changed configuration, and you can see that performance improves. So this is one we'd love your feedback on. If you try it out and you have ideas, or if it makes everything different for you and is wonderful, let us know, please. Okay, so we talked about a high-level kind of approach to getting involved in our SDK and understanding kind of the different getting started tools. We talked about some of the more in-depth performance analysis workflows you can go through. Yeah, we have a lot more work we're doing, and we always want to understand your experience and make sure that we're focusing on the problems that are ailing you the most. So let's spend most of the rest of the time here on Q&A. I'd love to hear back and make sure that we're understanding what you're going through.
Hey, love the tools, but don't love Windows. Will you support Linux potentially in the future for any of your tools?
Some of our tools do work on Linux.
I know RenderDoc doesn't, and so same with the MetaQuest Developer Hub. And
that's right.
Yeah.
Linux is definitely a platform we know and love. Unfortunately, it's a very small cohort of our developer base, and so we do try to bring things to it.
I suspect it will be growing in the next year. So
yeah.
Yeah. Cool.
So yeah, we definitely want it to succeed. Let me know what the biggest pain points are there for you.
Yeah. Cool.
So I'm the shoe in the gears here every year, where everything is Unity based. Not everything. You mentioned Android Studio and OpenXR a little bit, but are things like Perf Analyzer going to be available for Android Studio and OpenXR? How long will it be Unity only for? I don't use Godot, but I'm just curious about just generalizing this a little bit more across different IDEs and different kinds of engines.
Yeah. So Performance Analyzer actually is engine agnostic, so that
Okay.
one does work across, especially with Godot, it works great. But Runtime Optimizer, for example, is something that could provide a good template. We don't currently have an implementation of it for Unreal or Godot or native, but you can read the scripts in what we've published. It's something
Okay.
you could replicate in those environments. But yeah, definitely love Godot, love Unreal, and we just prioritize oftentimes where the most developers.
Totally understandable, but I have to ask.
But as for cross-platform, that is very important to us as well. I know that many developers want to ship to multiple stores and make all the revenue you can with the work you've done. So we're not trying to lock you into our platform. These tools are generally trying to create benefits for you that you probably will be able to leverage across other. We can't support those platforms directly, but if you're making a Steam VR app, for example, we want you to make all the money you can.
I've generally found that using the Quest tools to optimize something makes it faster everywhere. There's never been a case where optimizing for one slows down, or is sometimes maybe it's net neutral on another one where it's given GPU isn't as sensitive to something or whatever. But I agree. You mentioned that with tile rendering, distributing the tile compute means that different tiles can complete at different times. It wasn't quite clear to me in the tooling how you surface this tile is the longest tooth of this particular compute shader or something like that.
Oh yeah. So RenderDoc has many views, and one of them is render stage tracing. So
Okay.
if you load up a render stage trace in RenderDoc, you can see the tiling behavior, and you can actually see like when a particular draw call, how it's playing out on each tile, and then you can get heat maps, and you can get much more per tile information that way. Also, the PIL gives you a lot more in-depth.
PIL?
The profiler interface library we get from Qualcomm. So that's exposed through RenderDoc, Perfetto, and Runtime Optimizer in different ways. And especially in RenderDoc, you get the most kind of like low-level, like direct in-context access to that information, so you can really make sense of it.
Is PIL the sort of kind of underlying shared component underneath a bunch of these things? Or?
Yeah, we use a bunch of different backends, but the ones you should really know are Perfetto, is a lot of our CPU kind of begin-end timers. We also have the PIL, which is kind of streaming statistics, and we also get like render stage stats from that. But that's kind of the graphics driver performance statistics. And then there are other backends such as Tracy and others out there. But yeah, we also expose the PIL information somewhat more directly through OVR GPU Profiler. So if you bring up ADB Shell, there's a program that comes installed on your Quest. You can just run called OVR GPU Profiler that'll just print out some of those statistics directly to standard output.
Yeah, I'm just aware we have quite a few questions to go through, but we can continue just after this session. Thank you.
Up until this presentation, I wasn't aware of the MetaQuest dedicated build target in Unity. Is that any deeper than just another button for the Android build target?
That is a really good question. So the purpose of the Quest build target is to kind of, it makes it behave, like previously, Quest was just a configuration of Android. And it still is, actually. The way that this is implemented is Unity's kind of clubbing the settings together based on whether you're using Quest or using some other build profile. So there are build configurations. You can do other sub-targets of Android, for example, if you're doing wearables or something like that. But the cool thing about it is that it'll change configurations, potentially resources and assets in tandem with each other. So you don't have to like go in and write a ton of editor scripts to make sure that you're in the right configuration. And it also protects your Android code path. If you have, all your stuff tuned in URP, or you have like a bunch of different things in your project that are specific for Android, you can switch your assets over to the Quest version and so on.
Thank you. The short answer is yes, and a lot of the things again that you could see on project setup tool in terms of like automatically checking that your project is running specifically for Quest are still there.
But the Android is still like the same? Because
Yes.
you don't have to use direct Quest.
That's right, yeah.
It will be the same, but also the Quest, right?
That's right, and yeah, you could conceivably have like a generic OpenXR, or if you have like a Pico build target or something like that, you may have other Android-based headsets. You can have like build configurations for each of the major configurations you want to run in. So then it's meant as like an isolation, like modularity, and it helps you kind of protect the different configurations from each other.
Hi. So I know that you guys said that Vulkan is sort of like the build, like the render API that you should usually target. But in my experience, like generally, like I've found that GLS is like actually performing better in some cases.
It can.
And it has worse CPU performance pretty much. But looking into it deeper, we found that like sometimes it's URP's fault for like doing multiple resolve passes or other like inefficiencies and incorrect use of Vulkan. Do we know if that's something that Unity and you are like working together on to try and like improve in the future so that we can just switch over to Vulkan and forget about GLS?
Yeah, yes, so that any cases like that, first of all, would be surprising to me, but I mean, it's not surprising. There are cases where if the GPU is not fully utilized, it may be a couple % slower, but that can be fixed if we're made aware of it. Yeah, so our intent is to eliminate all of those kinds of disparities and make it categorically faster.
Yeah. So we're still on 2022.3, but we're looking at migrating to 6.2. Do you know if like that kind of stuff is more likely to be resolved in the newer version of Unity?
So it's a complex like mapping, right? There are cases that are slower and faster. We've been trying to make like all of the cases faster, and we've prioritized based on frequency and impact. But there are still some straggler use cases that if you're running into anything, let me know, please. So I'll be happy to follow up with you afterwards. But yeah, it can certainly happen. The way that GLES is implemented, driver writers had more control over exactly how the pipeline's being scheduled, and now Unity would have to do as good of a job now as the driver writers did. That just takes time.
Yeah, because we're looking at like writing a custom render pipeline to kind of sidestep all these issues and sort of just specialize, particularly for our game's needs. Like I was the tech lead on North Star, and the graphics lead is our new graphics programmer. So he's going to be making a custom render pipeline. So it'd be interesting to compare them once it's ready.
Awesome, love to talk
Anyway,
more.
thanks.
So we're going to take the rest of the questions outside, but let me just very quickly recap the presentation, what we talked about. We'd love to take your questions just outside. We're going to get it out in a second. So putting it all together, right, like how do you go from learning about new features to actually building, developing, optimizing? MetaQuest Developer Hub is there for you. Building blocks, project setup tool, all part of the Meta XR all-in-one SDK in the Unity Asset Store. Many of the new features are coming with V83. Meta XR Simulator is going to get a big update later in the year, with Immersive Debugger also getting an AI assistant right inside the headset. I'm particularly excited about this one. You can always dive deeper by selecting the right performance tools for your team's expertise. We have Meta Runtime Optimizer now, which makes almost like A/B testing for performance super, super easy. But of course, some of the more advanced tools to go deeper and really push what the device can do for you. And as always, you can submit feedback on the feedback hub inside MetaQuest Developer Hub. Some really cool features coming there. You can track the progress of like all the submissions that you have for us, and also through social. So thank you so much for coming. This was an excellent session. Thank you, and we'll be outside to answer more questions.